Chyba myślę, że mogę zaczynać. Witam wszystkich serdecznie na naszym dzisiejszym webinarze, który poświęcimy w większości zagadnieniom i oprogramowaniu, które pomaga w optymalnym doborze materiałów do projektów, nad którymi pracujecie i który to jest bezpłatnie udostępniany dla kół naukowych, które współpracują z nami, z firmą Ansys w ramach programu Ansys Academic. Jest ze mną także Piotr Buliński, nasz opiekun klienta i opiekun oprogramowania Ansys Granta. Cześć Piotrze.
Cześć Basiu, witam Państwa serdecznie.
Oraz Navid Manaj. On jest regionalnym opiekunem i człowiekiem odpowiedzialnym za rozwój oprogramowania Ansys Granta właśnie w naszej części świata. Hello Navid. Navid, are you with us? Okej, dobrze. Jeszcze spróbujemy to naprawić, ale wiem, że Navid na pewno do nas dołączy. Jeszcze ma chwilę czasu na to. Ja tymczasem przejdę do krótkiego omówienia tego, czym my się zajmujemy i na czym polega program Ansys Academic, bo wiem, że też w tym spotkaniu biorą udział osoby, które jeszcze z nami nie współpracowały i jeszcze tak dobrze nas nie znają. Tak więc zaczynając od samego początku, firma Symcom istnieje od 1997 roku, a to oznacza, że mamy naprawdę bardzo duże doświadczenie, zarówno jeżeli chodzi o współpracę z podmiotami akademickimi, z kołami naukowymi, ale także ze startupami i oczywiście z firmami w całej Polsce. Jeżeli chodzi o naszą współpracę z firmą Ansys, to jesteśmy channel partnerem, czyli dostarczamy to oprogramowanie, dostarczamy licencję i jesteśmy z tego bardzo dumni, dlatego że firma Ansys jest jedną z najważniejszych, jeżeli nie najważniejszą firmą na świecie, która właśnie zajmuje się dostarczaniem oprogramowania do prowadzenia symulacji komputerowych. I to, co my robimy, to jest oczywiście dostarczanie tych licencji, ale to tak naprawdę jest tylko początek naszej drogi, bo najważniejsze dla nas jest niesienie wsparcia, pomocy, współdziałanie z naszymi klientami, czy to na zasadzie prowadzenia szkoleń, wsparcia w prowadzeniu projektów, czy też tworzenia wspólnych wydarzeń, działania w ramach konferencji itd., itd. Tak naprawdę pole tych działań jest bardzo, bardzo szerokie i jest tego bardzo dużo. A teraz już przechodząc do samego programu Ansys Academic, teraz my działamy z ponad 30 kołami. I na czym polega ten program? Po podpisaniu umowy, takiego rocznego kontraktu na współpracę, koło naukowe otrzymuje dostęp do oprogramowania Ansys, które ma wartość około 35 000 euro. Ale to nie wszystko, bo jeszcze trzeba umieć dobrze korzystać z tego oprogramowania, dlatego my organizujemy specjalnie dla naszych kół bezpłatne wsparcie techniczne, bezpłatne szkolenia w ramach Letniej Akademii Symulacji. I tutaj można rozwinąć swoje umiejętności posługiwania się tym oprogramowaniem albo po prostu dowiedzieć się czegoś zupełnie nowego. Jest też również wsparcie marketingowe. Jeżeli koło tego potrzebuje, jeżeli tego oczekuje, to jak najbardziej możemy tutaj współdziałać w ramach mediów społecznościowych, brać udział w wydarzeniach organizowanych przez koła, ale oczywiście także nasze koła zapraszamy do udziału w tych konferencjach, w spotkaniach, które my organizujemy. I jeszcze tutaj wracając do Letniej Akademii Symulacji, czyli wracając do lasu, tutaj macie przykład zagadnień, przykład tematów, które poruszaliśmy, to jest chyba zeszłoroczne spotkanie, więc jak widzicie są tutaj zagadnienia i takie podstawowe, ale także bardziej już takie konkretne, zaawansowane. Więc tak naprawdę każdy student może wybrać, czy wziąć udział we wszystkich, czy w kilku, czy w jednym. To tak naprawdę już zależy tylko i wyłącznie od niego. Dobrze. Tutaj przygotowałam jeszcze takie przykłady tego, do czego koła naukowe użyły oprogramowania Ansys przy rozwoju swoich projektów. Mamy zagadnienia aerodynamiczne przy budowie samolotu albo bolidu, albo badania wytrzymałościowe elementów silnika, nad którymi pracowało koło naukowe ROPR. I ponieważ wiem, że też są z nami pracownicy akademiccy, to jeszcze tak szybko tylko nadmienię o innych możliwościach współpracy. To jest podpisanie umowy między nami, między firmą Symką a daną uczelnią. I wtedy jakby rozszerza nam się możliwe pole współpracy i tak naprawdę to zależy już od potrzeb danego podmiotu akademickiego, jakiego rodzaju by to miała być współpraca, bo już realizowaliśmy takie dotyczące czy to organizacji jakichś wydarzeń, czy to szkoleń dla pracowników, ale też dla studentów, albo wsparcie takich nietypowych inicjatyw, jak na przykład doposażenie laboratorium na AGH. W tym laboratorium były i są drukowane mieszadła na drukarce 3D i tutaj też pomogliśmy w doposażeniu tej sali, tego laboratorium. A tak już na koniec, zanim przekażę głos Piotrowi, chciałam Was zaprosić serdecznie na webinar, bezpłatny webinar, który się odbędzie 21 kwietnia. Będzie on dotyczył mieszalników, efektywnego mieszania, właściwego doboru technologii, ale także będziemy rozmawiać o tym, jak skutecznie mieszać materiały niestandardowe, na przykład materiały sypkie. Zaprosiliśmy także ekspertów, którzy uzupełnią nasze doświadczenia swoimi doświadczeniami i na tym wydarzeniu będzie obecny doktor inżynier Roman Bochenek z Politechniki Rzeszowskiej i pan Bogdan Gicala, który jest kierownikiem działu rozwoju w firmie Redor. Tak więc zapraszam do korzystania z tego zaproszenia i do rejestracji na nasze mieszalnikowe wydarzenie. A tak już na koniec zapraszam Was serdecznie do obserwowania nas w mediach społecznościowych, na YouTubie, gdzie publikujemy tutoriale pozwalające właśnie rozwiązywać problemy, z którymi najczęściej spotykają się użytkownicy oprogramowania i do kontaktu czy to ze mną, czy z Olą, która również opiekuje się kołami naukowymi i która będzie Wam udzielała wsparcia. To dziękuję jeszcze raz. Jeżeli macie pytania, to bardzo proszę zadawać je na czacie. Później do nich wrócimy i będzie na koniec naszego spotkania będzie taki czas na zadawanie pytań i na odpowiedź na nie. Więc jeżeli coś się pojawi w trakcie dzisiejszego spotkania, to zachęcam do tego, żeby zamieścić to pytanie na czacie. A ja już przekazuję głos Piotrowi.
Dziękuję, Basiu. Navid, are you here with us? Can you hear me? Not yet.
Yes,
Oh,
yes.
Okay, great. So let me say a few words before I will pass presentation to you, okay? And then we can start. So let's back to Polish. Szanowni Państwo, to dzisiejsze spotkanie ma na celu w zasadzie pokazać Wam, że są różne możliwości podejścia do doboru materiałowego. Wiemy, że z takimi wyzwaniami się mierzycie po tych kontaktach z Waszymi kołami, z osobami, które u Was zajmują się doborem materiałowym, szukaniu optymalnych materiałów pod kątem wytrzymałościowym, czy też minimalizacji masy Waszych prototypów. Wiemy, że taki problem istnieje. Z tego też powodu, chcąc wyjść naprzeciw, postanowiliśmy zorganizować takie spotkanie, na które zaprosiliśmy eksperta z firmy Ansys, doktora Navida Manai. I Navid przedstawi Państwu dzisiaj możliwości, które niesie ze sobą dobór materiałowy przy wykorzystaniu metodologii zaproponowanej przez profesora Majka Ashbiego. Ta metodologia będzie pokazana w takim bardzo ciekawym narzędziu, jakim jest narzędzie Ansys Granta. I tak jak Basia już wspomniała, w ramach programu wsparcia kół do tego narzędzia macie również dostęp. Więc jak macie w swoich kołach osoby zajmujące się doborem materiałowym, bądź też stajecie przed wyzwaniami tego, z jakiego materiału wykonać dany element waszego prototypu, no to tę odpowiedź na to pytanie możecie szukać właśnie w tym oprogramowaniu Ansys Granta. To jest oczywiście jedna z takich podstawowych funkcji tego narzędzia. Jest ich jeszcze kilka, o których wspomni Nawid. Ja, jako osoba zajmująca się na co dzień symulacją, wykorzystuję to narzędzie bardzo często do znalezienia własności materiałowych po prostu poszczególnych materiałów. No, do tego mi się akurat w moim przypadku najbardziej przydaje, no bo akurat zajmuję się na co dzień symulacją. Więc zachęcam Was do tego, żebyście korzystali z tego narzędzia. Zobaczycie jego wartość dzisiaj w trakcie prezentacji Nawida. I co jeszcze? Ja tu zawsze lubię opowiadać taką historię naszym kołom naukowym, które pokazuje, do czego może doprowadzić współpraca między nami, taka ścisła współpraca, dlatego też między innymi zachęcam Was do kontaktu z Basią czy też z Olą, takiego codziennego, i może doprowadzić do tego, że w przyszłości, za kilka lat, jak będziecie absolwentami uczelni, to z jednej strony możecie chcieć założyć własną firmę, która gdzieś będzie się dalej rozwijać w obszarach waszego zainteresowania, jak na przykład takie koło naukowe zajmujące się transportem szynowym z Politechniki Warszawskiej. To była grupa pasjonatów, która postanowiła wygrać konkurs organizowany przez Elona Muska. Konkurs pod nazwą Hyperloop. No i postanowili zbudować taki pociąg w tej technologii. No i udało im się wystartować w tych zawodach. Akurat w tej edycji nie wygrali, ale postanowili kontynuować to poszukiwanie swoich pasji, swoich marzeń i postanowili założyć firmę. Założyli firmę przy pełnym wsparciu z naszej strony. Przez kilka lat oprogramowanie praktycznie mieli za darmo w ramach współpracy związanej właśnie z taką młodą firmą, aż w końcu rozwinęli się na tak dużą skalę, że obecnie próbują tutaj, że tak powiem, rozwijać kolej w całej Europie. Nazywają się aktualnie Nevomo, przekształcili się z firmy Hyperpoland. No i to jest taki przykład, że wy jako osoby, które mają pasję do tego, czym się zajmujecie na co dzień, rozwijając swoje umiejętności nie tylko w tym programie studiów, który jest typowy dla wszystkich, jak również poza nim, uczestnicząc w różnych projektach studenckich, możecie doprowadzić do ciekawych rzeczy, możecie realizować swoje pasje i dzielić się z innymi ludźmi entuzjazmem, do czego Was serdecznie zachęcamy. No i mamy nadzieję, że będziemy w tym, że tak powiem, w przyszłości razem. To znaczy będziemy wspólnie się dzielić entuzjazmem, bo my taki entuzjazm akurat posiadamy do symulacji, o czym już Basia wspominała, natomiast Wy do tych aplikacji, którymi się zajmujecie. Dobrze, to chyba na tyle z mojej strony. Teraz, żeby już nie przedłużać, let's switch to English. So, Navid, floor is yours, so you can start teaching us about Granta Selector.
Fantastic. Thank you very much, Piotr, and thank you, Basha, both of you, for the kind introductions. Let me share my screen. Okay. Can you confirm that you can see my screen, please?
Yes, we can see.
Brilliant. All right, very good. Okay, so good morning, everyone, and thank you for joining this session in which we are going to explore how Ansys is currently supporting student teams in vehicle design through the usage of Ansys Granta Selector software. As mentioned, my name is Dr. Navid Manai. I'm part of the Ansys academic development team, So hopefully through the agenda that you can see here in the slides, we will be able to explore a little bit the Granta Selector software and how it can help you in designing your vehicles for the race competition that you're part of. So we have done the introductions in the beginning, at first I will provide an overview of the Granta Selector software itself. Then we will go a bit deeper into some of the ways that Granta Selector can actually support your vehicle design. The two that I've mentioned here are the ones that we're going to focus on. One is material selection for lightweighting, and the second, exploring environmental impact of material choice in designing your vehicles. And then finally, I'll explain a little bit of where you'd be able to get additional training and support if that is needed going forward. So by the end, we can have a Q&A session, and hopefully we will get to answer all of the questions generated during the session. So if you have any questions, please feel free to put them in the chat or in the Q&A session, Q&A section, and hopefully we will get to answer all of them by the end. Okay, so Ansys actually has a range of products that caters to the need for materials data and information management. These perform separate duties in academia and industry. For example, the Granta EduPack and Granta Selector are being used in academia for teaching and research purposes. And you can see a list of universities that have integrated these solutions in their curriculum. On the industry side, Granta Selector is used as the industrial standard for material selection, and Granta MI serves as the platform for materials information management. So you can see, of course, a list of some of the companies that have integrated these solutions in their workflow as well. Very good. So I'm just going to provide two examples of how these products are being currently used, roughly relevant to the subject of today, which is vehicle design in general. And so at Itergo, Granta Selector, so the software that you're focusing on today, is actually being used in conjunction with other Ansys simulation software in order to optimize the material that are being used for their components, and also, of course, the design through the simulation capabilities of Ansys. And as you can see, the code that we have here mentions that the integration of these two software is extremely helpful for them in the competitive environment that they are actually working in. And the second example is for Red Bull Racing. So as you can see, they are using our Granta MI solution in order to choose the right materials for their components and then store and manage that data both on testing and simulation data in order to be able to essentially capitalize on the amount of data that is generated through the design process. Okay, so let's say a few words in general about Granta Selector and what it is. So when it comes to choosing the right materials for your different components in your racing vehicle, or in general for any engineering component, we might be trying to do lightweighting or try to keep the strength of the material being used high. But what if we want to actually optimize the performance of the component through the material choice in a more comprehensive way, so that we are able to reduce the environmental impact, at the same time reduce the cost, prevent supply chain issues and material failure. So typically what is used in companies, research institutes, or in student teams is that the team goes to in-house expertise, if that exists. And so the material engineer within the team would either search the web or get in touch with material consultants or suppliers in order to be able to get a list of material that would work well for the application that they have in mind. But how do we make sure that that choice of material is actually the best choice that can be used here? How do we make sure that we have essentially considered the whole pool of material choices that would be available to us? In this case, Granta Selector could be helpful for you guys. So in order to be able to make smart material choices, we not only need to have access to an encyclopedia of materials data, but we also need powerful tools in order to interrogate that data. And this is what Granta Selector brings to the table. So you would have access to a comprehensive source of information on different categories of engineering materials, as well as powerful visualization, estimation, and screening tools in order to interrogate that data. So these tools include, for example, the Find Similar tool, with which you'd be able to rank different materials in terms of their similarity to a reference material. So extremely helpful, for example, for substitutional purposes. The synthesizer tool that enables you to essentially estimate the properties of hybrid structures. Eco audit that enables students to essentially investigate the environmental impact of their design choices throughout the life cycle of the component. So it is essentially a streamlined life cycle analysis tool. And exporters exist within the software with which you'd be able to export every bit of materials data into any CAD or CAE software that you're using within your projects. Okay, so let's say a few words about the data and tools that are available in the software. So there are two types of data that can be available in Granta Selector. There is the core material data, which is always available in Granta Selector. This is something that if Ansys is partnering with you within your student team, you do have access to this core material data. And then there is the advanced materials data that, if needed, can be purchased separately and added to this core material data. So within the core material data, we have two databases, Material Universe and JAM Curve data. So Material Universe is complete and comparable. Almost all the data sheets available, which is more than for more than 4,000 materials, have a long list of material attributes. It's easy to actually compare to see across all of these choices how, for example, yield strength is actually distributed using the visual tools that we have and the charts that you can create, as you can see in this slide. So it's a very good source of information for early stage screening in design. And the JAM Curve data provides information on more than 8,500 materials. These sort of information is essentially curve data. So it includes temperature dependent material properties, as well as magnetic pH curves, fatigue strength curves, and true stress strain curves. This is provided across a range of physical states and a range of temperature, which could, depending on the material, begin at minus 270 to more than 5,000 degrees. So extremely helpful, for example, for simulation purposes. Okay, so that was the core data, but depending on your need within your design, you will also be able to add more advanced and specialist data sets to this core data. We have data bundles for metals, polymers, composites, for aerospace and medical applications, and additive manufacturing, and finally for eco design. So these, as I mentioned, could be added essentially as add-on data bundles to this core data. To begin with, I would think that this core material data would probably be sufficient, but I will provide in the slides that I'll send out after the meeting a description of what is actually included in each of these additional data bundles, so that if you think they would be helpful for you, you can get in touch with Basha and Piotr, and we can, arrange another session or provide more information and essentially discuss how you'd be able to access these advanced materials data. Okay, so let's explore some of these tools. So we have Engineering Solver available in the Granta Selector software, with engineering solver, you'd be able to convert engineering requirements into material properties. For example, you can, as input, mention to the software what is the geometry and the loading condition that the component is experiencing, and the software will provide you with a minimum, for example, yield strength or Young's modulus that you have to keep in mind when you're choosing the right materials for that component. With comparison table, you can compare in a side-by-side table all the different attributes of many material choices that you have in front of you, and go a bit deeper to be able to see how, for example, they compare to a reference material. Of course, you can create visual charts, Ashby charts, bubble charts. They have many names to be able to compare attributes of different materials with different categories of materials. Performance index finder. This is one of the tools that we're going to be using today. So I'll explain a little bit more when we get to it, but it essentially allows you to find the relevant performance index for the application that you have in mind. As I mentioned, there are exporters in the software that would enable you to export this material data to most commonly used CAD and CAE software. Synthesizer tool, I mentioned a little bit in the beginning. So it provides numerical models to estimate properties of hybrid structures. So as you can see, we have models for cellular structures, composites, sandwich panels, multi-layer materials. This is something that we're going to be using today as well. Find similar tool, I explained this a bit in the beginning. Eco audit tool, we will focus on eco audit as the second portion of this session. So as I mentioned, this is essentially a streamlined lifecycle audit tool. And of course, when you're done with your material selection, you have the choice to actually create a comprehensive a selection report to include, for example, in your report that you're providing to the team that is actually judging your performance as well. Okay, so of course, there are many capabilities in Granta Selector that can be helpful in the process of vehicle design, and I've mentioned a few of these in here. There are capabilities in Selector that would help you in lightweighting through material selection. The analysis of environmental impact in design is another aspect that can be analyzed using Granta Selector. We can do substitution and material selection with the software. And of course, there are some capabilities in the software that would help you in early stage battery selection and sizing. So for today, with the input from Piotr and looking at some of the criteria that the teams are judged upon in their racing competitions, we've decided to focus on the first two aspects. But if you require further information about any other capabilities, please feel free to get in touch with us after the session, and we can provide more information as well. So on the capabilities for lightweighting through material selection in the Granta Selector software, we have prepared a case study for this, and like any other selection project, when it comes to selecting the right materials for lightweighting, we are going to be using the systematic material selection methodology created by Professor Ashby and his colleagues in University of Cambridge. And in this process, we start with all the materials that are available to us, and we break down the design requirements into three categories of function, constraints, and objectives. Function is what we expect the component to be able to do for us. So for example, if we are looking at a pillar in a building, we would expect that pillar to be able to essentially tolerate partial load of that building, right? So we can expect the function of this pillar to be a beam in compression in a strength limited design. And constraints are the essential conditions that must be met. So for example, if within our design, we are dealing with a minimum yield strength, this would be considered a constraint, and we can essentially use these constraints to screen out unsuitable materials accordingly. And finally, objectives are what we are trying to minimize or maximize. So for example, in this case, because we are trying to do lightweighting, minimizing weight and minimizing mass essentially would be our objective. So as I mentioned, we can use constraints to screen out unsuitable materials first. And then with the remaining materials, we can use objectives to rank them in terms of their performance for the application that we have in mind. And by going through this list, we can hopefully identify a list of final candidates that would be optimal for our design. If you would like to get more in depth on any of these concepts, of course, there are Professor Ashby's textbooks that provide more information in this regard. Okay, so speaking of performance, I want to say a few words about performance of engineering components and how they are measured. So, of course, when it comes to performance of engineering components, we can use performance equations, and part of that performance equation is always materials. So the performance of a component can be measured and governed by either single material properties or more typically by a group of material properties. So in the first case, for example, if we are concerned with the tensile strength of the material, then that would be, what would be essentially governing the performance of the component in terms of the material side of things. But of course, this is typically we are dealing with a group of material properties. In this case, as you can see, specific stiffness. So essentially, Young's modulus divided by density is what is governing the performance of a component. These material properties or groups of material properties are what we have branded as material performance indices. So these can be helpful for us in identifying the right, essentially, materials that we're going to be using for our applications in mind. So how do they help? Well, as I mentioned, we use constraints to filter out unsuitable materials. And then we use these material indices to rank the performance of materials essentially for the component that we have in mind. So the materials with the largest or the smallest performance index would be the ones that would be optimal for our application. This depends on the type of design, of course, that we have in mind. How do you identify these performance indices and the relevant ones that you need to consider for specifically the component that you have in mind? Well, there are a couple of choices for this. For example, you can use the help section within Granta selector, and there is a list of performance indices for different kinds of standard design. So for example, if we want to do lightweighting in a stiffness limited design, then the software would let us know for different functions what would be the right performance index to minimize or maximize in order to achieve this objective. So that would be one way of finding the right performance index. You can, of course, sit down and derive them directly as well. And I say a few words about that in the coming slides. Okay, so for the case study that we have for today, we are going to look into finding the optimal materials for an automotive door panel. So we are going to be using this case study to explore some of the tools available in the software as well. So the design requirements that we are dealing with are going to help us identify hopefully materials that have a better performance than a typical material which is used for this application. And I've included this typical material on the top right corner. This is YS140 cold rolled steel. And the design requirements that we have for this application in terms of function, we are dealing with a panel in bending in a stiffness limited design. So we are essentially trying to control and limit the amount of deflection as it happens when this is essentially working as part of a car. In terms of the constraints that we have a range for our service temperature that the material would have to be able to tolerate. So for the maximum service temperature, the material should essentially have a maximum service temperature of 90 or more So essentially this value is the minimum amount for our maximum service temperature. For minimum service temperature, the material should have a value of -20 degrees or less. So again, this is the maximum value that the material should have for its minimum service temperature. We have a minimum value for yield strength and fracture toughness. We want the material to be able to resist rain and petrol or gasoline in an excellent fashion, and we want the material to be able to be manufactured by specific manufacturing methods of composite forming, sheet deformation, and molding processes. And in terms of objectives, as mentioned, we want to minimize the weight and also the cost of producing this component. And I've identified the right performance indices in order to achieve these objectives. So as I mentioned, of course, you'd be able to find these performance indices in the help section of Granta Selector, but you would also be able to sit down and derive them yourself. I've included the derivation of one of these performance indices to help us minimizing weight. I'm not going to go through it, but of course, this is available when you get the slides, or if you would like me to say a few words about them, please put something in the chat and I can explain further in essentially the Q&A session at the end. Okay, so with that said, let's jump into Granta Selector and essentially follow up on the case study that we just started talking about. So this is the home screen of a Granta Selector. As you can see, it includes the databases that I was discussing in the slides. So we have the material universe and the jam curve data. These two are the core data always available in Selector. Everything else that you can see, the other databases available here are the add-on data bundles that essentially can be added to these core databases. Okay, so let's explore the structure of a typical data sheet within the material universe, for example. And for this, we can, go and have a look at the typical material that I just mentioned is used for this application, the YS140 cold rolled steel. So in order to find that material, we have a couple of choices. We can use the browse section or the search functionality. Within the browse section, as you can see, we have data sheets for different categories of material properties for ceramics and glasses, fibers and particulates, hybrid materials, including composites and natural materials, for liquids and gases, magnetic materials, metallic alloys, and polymers. So of course, we are looking into finding a specific kind of steel. So it would be under metallic alloys, ferrous materials. I know that this specific alloy can be found under microalloy and high strength steels. This is the drawing quality. So there it is, YS140 cold rolled. So if I double click on it, the data sheet for this material pops up. And it includes a designation of the material according to a Euro number, if I remember correctly, and also the different trade names that is used for this material in industry. Typical uses of the material is available. As we can see, one of these typical uses is automotive parts, including for body panel. So no surprises in the fact that this is being used for this application. We also have some compositional information of the material. As you can see, the price and density of the material is available. We have mechanical properties, including Young's modulus, yield strength, Poisson ratio. As you can see, we have the chart for true plastic stress strain curves. And scrolling further down, we also have curve data for fatigue strength. In terms of impact and fracture properties, we have fracture toughness, for example. If there are some of these attributes that you're not sure about what they are referring to. For example, there is this information icon that you can click on. So let's click on the information icon for fracture toughness. And this provides you with a design note that would help you with some brief information about, how you'll be able to use this attribute when you're trying to select the right materials, or in general in designing the component that you have in mind. If you want to go a little bit more in depth, you can click on the science note, and as you can see, a comprehensive source of information pops up. This could be very helpful for self-learning purposes. And in here, we have detailed information about fracture toughness, how it can be measured or calculated, what are the other material attributes that are associated with fracture toughness. And if you want to go even one step further, there is a list of further reading with textbooks that you can find, information about fracture toughness. So, you can go and have a look in these textbooks as well. Okay, so let's go back. We have thermal properties, including melting point, thermal conductivity, specific heat capacity, electrical, magnetic, and optical attributes are available. We have identified whether the material could be hazardous to health or environment. If the material would have supply chain issues currently or in the future is identified here as well. How well the material can be processed using different processing methods. How well the material would be able to withstand different environments in this durability section is identified here as well. We have eco properties of the material in terms of embodied energy and CO2 footprints of its primary production, as well as its processing. So you can see that information is also available. And we have some information about the end of life attributes of the material. So for example, whether it can be recycled or not, and if it can, what would be the environmental impact of that recyclability is mentioned here. And at the end, we have some more information about the different kind of these designations that can be used when referring to this specific material. So if you're searching for any of these keywords, this datasheet essentially would be popping up in your results. And by the end of the datasheet, we have links that would take you to other parts of Granta Selector that would be relevant to specifically this material. So for example, if we go into the producers link, it would show us a list of main producers of this material, and they all have their own dedicated data sheets. You can go there, find information about their websites, the year that they started creating this material, and so on. So let's go back. Just want to show you one last thing here of, for example, process universe. So if we click on process universe link, it would show us all the different processes that would be compatible for joining, shaping, and surface treatment of this material. And of course, all of these processes have their own dedicated data sheets. So let's go into, for example, let's go to mechanical welding. Have a look at friction welding, and you can see that I'm not going to go through the datasheet, but the datasheet is available with different attributes of this process. So you can have a look and learn more and see if that process can be what you would like to be using for producing your components. Okay, search is very straightforward. You essentially search for the keyword that you have in mind. This could be a material, a process, an application. So for example, in our case, automotive door panel. If I search for that, as you can see, 27 materials show up. And as you can see, the material that we just looked at is the last result. So any of these materials that essentially have these keywords available in these in their data sheets, they will pop up, and you can see that these keywords are actually highlighted to help you understand why you're actually in this data sheet when you have searched for this keyword. Okay. So this is how you'll be able to, navigate your way through the different kinds of data sheets available in the software. let's go back to our case study that we have for today and material selection for lightweighting of a car door panel. So for that, we can use this essentially capability on the main toolbar called chart select. So this is where we can, essentially carry out selection projects as well as create visual charts. So let's click on that. And as you can see, when we do so, we are directly in a selection project. So the first logical step is to identify the pool of materials or processes or any other information that we are trying to select. So in this case, we are going to essentially have a look at the entire, or we can have a look at the entire material datasheets that are available in Material Universe. We can essentially narrow down our choices into a specific category of materials, as you can see here. But we also have the option to define our own subsets. And this is an option that I'm going to be using for this case study. There are a couple of material categories that I am interested in and that could be helpful for this specific application of a car door panel. And they include, for example, within composites, I want to have polymer matrix composites in my pool of selection. I also would like to have ferrous materials and aluminium alloys. And finally, I would like to include thermoplastics within my essentially pool of materials that I'm choosing from. So when I click on OK, you can see that there are more than 1,600 choices that we currently have. We narrowed this down from more than 4,000 to 1,600 by defining our own subsets. The second logical step is to identify the reference material that we are trying to, find better performing materials for. So the reference material can be identified here. As I mentioned, this is a cold rolled steel, so I can easily find it in the category of drawing quality. There it is. So our reference is now identified. So at this point, we can essentially create a visual chart in order to compare the performance index of these 1,600 materials that we have in our results and see which of them would essentially have a better performance for this application. So in order to create a visual chart, we can click on chart index. The software asks us to populate the y-axis and the x-axis. If we are choosing single material attributes, we can use this category and attribute functionality to do so. We can also use this advanced option in order to build up any combination of material attributes that we would like to have on our y or x axis. In this case, I'm going to be using this performance index finder tool that would help me actually identify the right performance index for this application. So here, what you would need to do is to identify the function that you're dealing with. And as I mentioned, we are dealing with a panel embedding. So this is what I'm going to be choosing. But as you can see, there are many different mechanical functions available to choose from. We also have abrasion resistance functions and thermal functions, and finally electrical and barrier functions as well to choose from. So in this case, I'm going to choose panel embedding. We are in a stiffness limited design, so I'm going to keep this as it is. And for the y-axis, I want to optimize the mass of the component. So as you can see, when we identify these, the software automatically shows you what is the right performance index that we have to be keeping in mind and exploring for this purpose. So that is going to be put on my y-axis. For the x-axis, I'm going to do the same thing. So panel embedding, stiffness limited design. This time I want to optimize the cost of the material that we are choosing. So now we can click on OK and the visual chart pops up. Of course, you can easily compare different all of these materials in terms of their essentially mass per unit of stiffness and cost per unit of stiffness. These are the two performance indices that we just identified. We can also bring in the different material categories that are available on this chart. So because of the self-defined essentially materials that we are considering for this application, we are of course just have plastics, composites, and metallic alloys on the chart as well at this time. But if we were looking at all the materials available, of course there would be other categories on the chart as well. So you can of course also drag, click and drag to identify single and specific materials on the chart as well. And so this is very much interactive and a visual way of looking at the materials that are available to you for this component. Okay, so of course, 1,600 choices is a lot. So we need to narrow this down a bit more. In order to do this, as I mentioned, we can apply the constraints that we discussed. And in order to apply the constraints, we can use the limit stage. So when we click on that, different categories of material attributes pop up. And if we have the right information, we can choose a minimum and a maximum, or a maximum essentially for any of these attributes, and we can apply these to screen out unsuitable materials. So in terms of our mechanical properties, we have a minimum for our yield strength. So let's put that in, 22.4. And we have a minimum for our fracture toughness. So let's put that in as well, 1.17. We have a range of temperature for thermal, essentially for our service temperature. So as I mentioned, for maximum service temperature, we have a minimum value of 90 degrees. And for the minimum service temperature, we have essentially a maximum value of -20 degrees. This could be a little bit counterintuitive. So if you would like to, essentially go a bit deeper, of course, the science notes for these attributes could be very helpful. And if you're still struggling to essentially figure out why we are putting the minimum value for maximum service temperature, for example, again, put that in the chat or get in touch with me after the session. I'll be happy to provide more information on this as well. Okay, so going forward, we have some durability information as well. So let's put that in. So as I mentioned, we want the material to be able to withstand fresh water or essentially rain. So I'm going to put acceptable and excellent for that. And then petrol is essentially an organic solvent. So I'm going to put acceptable and excellent here as well. And so that was it. That was the constraints that we had available on the chart. So let's apply them. I'm actually going to change this to having just excellent, if that's okay with you, instead of just having acceptable. There we go. So if we go back to our chart, we can see that we have now narrowed down our choices to 590 choices. So let's remove the material categories here. So in here, as you can see, many of our choices have now gone gray. These are the ones that have failed our selection stages. And we can essentially remove them from the chart by clicking on hide failed records. We can focus on the materials that have passed our selection stages by clicking on auto scale. And so as you can see, we can easily figure out where is our reference material on this chart by clicking on highlight reference record. And by clicking and dragging, we can see that this is our reference material. So we are at the moment in a scenario where, as you can see, there is no material available on the chart that has at the same time best performance in terms of minimizing cost and best performance in terms of minimizing the mass of the component. So we are in a trade-off scenario, essentially. So we need to have a strategy to be able to find an optimal material that would be able to essentially meet these two requirements at the same time. So when we are in a trade-off scenario like this, where we have two performance indices on the X and the Y axis, we can use this trade-off curve and manually draw this on our chart. So this is one of the concepts that Professor Ashby talks about in his textbooks as well, and within the systematic material selection methodology. So if you want to have more information about trade-off curves in general, please have a look on the help section. Just to say a few words, the materials that are closer to this trade-off curve are called, or closest are called non-dominated solutions. And they essentially have a better performance in terms of both of these two essentially performance indices compared to materials that are further away from the trade-off curve. So in this case, as you can see, our reference material is actually performing quite well compared to other ferrous materials on the chart, which are all shown in this green color. In terms of the polymers that are available on the chart, which are shown in blue, the best performing polymer seems to be this essentially polypropylene, which is filled with 30% of glass fiber. And we have this composite material, which is essentially a carbon fiber reinforced PEEK polymer on the chart as well, which is performing quite well in terms of its lightweighting attributes. But as you can see, it is quite expensive for this component. So at this point, we have essentially 3 candidates for this application, and it depends on the use case that we have in mind when it comes to this corridor panel. If we are looking to use this corridor panel in mass production, for example, if you're designing a family car, which millions of it is going to be produced, then maybe keeping the minimization of cost in mind would be more important than minimizing the weight of the material. So in that case, this cold rolled steel would make sense, which is why it is the typical material used for this application. Or you might be designing a race vehicle, a race car. In that case, maybe cost is less important. Maybe minimizing the mass and the weight of the component is much more important to you. And then this carbon fiber reinforced polymer would be the material to go with. So this is essentially depends on the judgment of the user at this point to choose one of these 3 materials. In order to help that judgment, we do have a capability in the software called comparison table, as I mentioned, which you'd be able to compare attributes of all these materials with each other to essentially make a final selection. So in order to create a comparison table, you essentially right-click on any materials that you would like to have on that comparison table. And so you can see one of the options that you have is add to comparison table. So when you do so, the comparison table automatically pops up. I'm going to go back and add our carbon fiber reinforced polymer as well. There we go. So as you can see, we are able to compare all the different attributes of these 3 materials in a side-by-side table. And what I usually do is use the percentage of change. I think it makes it a bit easier to actually compare their attributes. So by going through this, it essentially helps you not only to compare the attributes of these materials, but also to have a look and see if you have missed one of the design requirements that is quite important to you within your systematic material selection methodology. To give you an example, in this case, if we scroll down to the eco properties of these materials, let's go down bit more, you can see that the essentially steel is recyclable. However, the other 2 candidates are not. So if that is something that is important to you in your design, then we can go back, add recyclability to our limit stage, and screen out materials that are not recyclable. So it provides you with a bit more in-depth information of which of these choices that you have identified as your best candidates would actually be performing better for the application that you have in mind. Okay, and just to mention here that the ones that are highlighted are the attributes that are significantly different to the reference material that we have, or as you can see, by more than 10%. So this is of course customizable as well. If you would like to change that, you have the option to do so. I'm going to mention one last thing here. If you are actually looking at the choices that are available to you on the chart, and you think that the materials that would actually be very helpful for us would be the materials that are closer to the origin of the graph here, and there seems to be a gap with no materials available here, you might be thinking, okay, maybe I can actually, prototype a material. Maybe I can make a new hybrid structure that would help me essentially have some materials available in this gap that is closer to the origin of the graph. So this is where the synthesizer tool could be very helpful for you. So if I click on the synthesizer tool, as you will see, there are, as I mentioned, numerical models that would help you in estimating the properties of these hybrid structures. So for example, if I go into the numerical model for continuous fiber composites, you can see that you have the option to identify the fiber orientation in this composite. I'm going to choose to be using quasi-isotropic. You can identify the matrix of the composite. So here I'm going to choose to have polypropylene. So let's find polypropylene. There we go, a little bit more. There it is. And I'm going to choose one of the unfilled versions because I want to essentially fill it myself. In terms of the fiber, we have many different choices, but I'm going to be using one of the natural fibers to increase the green impact of the product, and also, for example, flax fiber provides good vibrational attributes as well. So that could be a good choice for us. So I'm going to have that as my fiber. You can identify the amount of fiber that you have in your matrix. I'm going to keep it at 10 to 50%, and you can identify how many materials you would like the software to synthesize and estimate their properties. And finally, you just name the essentially matrix and the fiber, and you click on create. And by doing so, you can see that now we have new materials available on the chart, which we just synthesized. Of course, we can click and drag to identify them. And all of them have their own dedicated data sheets available. So I'm going to click on one of these, and you can see that in the datasheet for the synthesized material, we have properties including for mechanical properties, physical, thermal, electrical, and eco properties, which are all estimated using the numerical models of the synthesizer tool. And at the end of the datasheet, of course, there is a notes section which shows you the choices that you made for this datasheet to be synthesized. Okay, I think that essentially concludes what I wanted to show you in the first part of or the first case study that we had in terms of material selection for lightweighting a car door panel. So let's go back to our slides, and I want to remind you to please, if you have any questions, please feel free to put them in the chat, and hopefully we can get to all of them by the end of the session. So this is essentially what we just got. As you saw, Selector is able to actually help you identify the best performing materials, and also helps you estimate the properties of hybrid structures using the synthesizer tool. Okay, so I also want to say a few words about how you'd be able to, link these material project. So with Granta Selector, you have the option, of course, to carry out material selection, and then you can export this data into your simulation software, optimize your design in there, and then you can create essentially iteration loops in order to finally create your own optimal product. So for this purpose, we have a couple of capabilities in Granta Selector. Of course, we have exporters within the software that would help you, export this data into CAD and CAE software that you're using. There is the materials data for simulation subset, which includes about 740 materials within the Granta Selector software. These essentially have more temperature-dependent curves and more data on fluids and gases are available for these 740 materials subsets. We have also integrated, of course, Granta Selector into Ansys Workbench. So you don't even need to essentially export this data as a file to Workbench. You can essentially launch Selector within Workbench, do your own material selection, and you would have that data or that material that you reach as the optimal material included in your material library or engineering library of the design that you're doing. So it is essentially fully integrated into Workbench. So this is just a slide that shows you how you can export this material information. So essentially on any data sheet that you're dealing with of the material, or on any label of the material, if you right click, there is the option of export to at the end of the drop down menu, and you can choose the essentially software that you would like to export to. The software asks you if you would like to, export temperature dependent or temperature independent type of data, and then you essentially export it as a file, and you can import that file into any or most commonly used simulation software that you can see on this list. If you're using CAD or CAE software that is not included on this list, you could, you need to do some exploration and seeing what is the format of the file that software that you're using accepts. If that file format is similar to any of these softwares that are available in this list, then you'd be able to use that file anyway, although that software is not listed on drop-down menu. As I mentioned, the selector is, of course, directly integrated into Workbench. So as you can see, it can be used as the material library for your simulation. If you would like me to show you live how this can be done in Workbench, please let me know in the chat, and I can show you in the Q&A session of how this can actually be achieved within Workbench. Okay, so the second part of essentially the session that I have prepared for is investigating the capabilities that are available in the software for analyzing the environmental impact of your material choices within your design. So of course, understanding the environmental impact of your design choices and material choices throughout the life cycle of the components that you're creating is becoming increasingly important. And this is not something that I need to, say too much about. But on top of that, we've noticed that in most of the or some of the essentially race competitions and student teams, having some information about the environmental impact of your choices as part of the final report that you provide to the judges of the competition can be part of that criteria, or at least give you some bonus points when you're being judged for your design. So hopefully this can be these capabilities can be helpful for you in achieving those bonus points. So when we are talking about essentially life cycle thinking, of course, this life cycle starts from extracting the natural material and going into producing the material itself, and then you go into the phase of manufacturing the actual parts, using that part, and then finally figuring out what you would like to be doing with that part at the end of its life. So there are different choices, of course, and all of these have specific essentially impact on the environment at each phase of life. So Granta Selector and the Eco Audit tool specifically within Granta Selector can help you in essentially investigating this impact in different stages of the life. So it essentially calculates for you the energy requirement and carbon footprints of the choices that you're making in different phases of the component that you have in mind. So the workflow that usually can be used in eco design projects is you essentially run a quick eco audit. This helps you identify the phase of life that has the most impact on the environment. Then you'd be able to use the capability within the eco audit tool to investigate what if scenarios and compare the choices that you have made with alternative choices in a live fashion. And then you can use other capabilities within Granta Selector to, for example, as I showed you, identify materials that are lighter to reduce the amount of, for example, fuel that needs to be used for if you're dealing with a vehicle, or choosing materials that have lower embodied energy. This can be helpful in reducing the environmental impact of your design choices. So how does it work? Well, there are two types of input that are provided to Eco Audit. One is the user input. This includes the bill of materials that you're using for different components within your product, the manufacturing processes that are being used for each of those components, if there are going to be transportation needs, and what are you actually doing at the end of life of each component? Are you throwing it away? Are you recycling it? So that is the user-defined information that goes into Eco Audit. And then Eco Audit takes data from the data sheets available within the software. This include, for example, the embodied energy and carbon footprints of materials, of processing those materials, and for their recycling as well. So it takes data from those data sheets and then provides you with output, which can be in a visual chart, as you can see on the left hand side on the bottom, or it can be in a detailed report that you can actually essentially export, copy and paste, whichever is easier for you, and include it in the report that you're providing to the judges as well. Okay, so the case study that we're going to be looking into to show you how this actually works in action is going to be on the same component. So the car door panel, this time we are looking into what would be the environmental impact of different materials that we are choosing for essentially this component. So in here, as you can see, we are in a scenario in which the car door panel is being manufactured in the US. It is being shipped to Australia, and the car that this car door panel is a part of is going to be driven for more than 10 years, and I've included for the distance that it's covering as well. So we are going to explore three different essentially material choices here. We are going to start by our reference material, the cold rolled steel. And this one would essentially have a weight of 18 kilogram. If we essentially use an aluminium alloy instead, then we can reduce that weight to 10 kilogram. Of course, all of this can be essentially identified using the material selection that we just went through. And finally, the other choice that we're going to be considering is the carbon fiber reinforced epoxy resin. And that one would have a weight of 7.5 kilogram for the car door panel. So we're going to see how these different options actually have an impact on the energy requirements and the CO2 footprints of our choices. So for that, let's jump into the software again. And as I mentioned, we need to be using the Eco Audit tool, which is available on the main toolbar. If I click on it, as you can see, the Eco Audit tool pops up. And so there are a couple of fields that we need to fill in. This is the user-defined information that I was talking about in the slides. We can name the component itself first. So I'm going to name this as a steel bill of material that is essentially just the steel, so we can easily find the actual alloy. We have the option to choose how much recycled content is being used to create this component. So you can, choose to be using all virgin grades, so essentially no recycling material. You have the option to choose reusing the parts. So essentially, you're not using any new material for this component. As an example, if you're using some of the parts from the previous designs of the racing vehicle that you're using this year, then for that you can essentially use this reuse part, and that takes out any energy requirements or CO2 footprints for manufacturing of that component within the life cycle analysis. In our case, I'm gonna directly put 50%, so you can actually type in the amount that you have in your recycled content. In terms of the mass, as we mentioned, for the steel, it's going to be 18 kilograms. The primary process that I'm being using for manufacturing this part is roll forming. And in terms of secondary, you can identify a secondary process if that is something that you're going to be using in manufacturing the part. So in this case, I'm going to be using cutting and trimming, and what else? So the essentially end of life scenario that we have for this option is going to be essentially recycling it. And the amount that we are going to be recovering here is going to be 85%. So, of course, if you want to have more information on how you can, or what type of information, or what are your choices in filling in any of these fields, all of them have their own information icon. You can click on them. It would take you to the help section and provide you with the information of how this essentially form can be filled with the essentially choices that you want to make. Okay, so for joining and finishing, we have the option to put in even more processing methods here. So I'm gonna put a joining process here, and this is going to be fastening. Okay, and there we go. The amount I'm gonna put as 40, and unit is essentially there is no unit for that. It's just a number of fasteners that we're going to be using. I'm also going to be using finishing process, which is going to be painting. There we go. And for this, I'm going to be using for essentially meter square. This is going to be covering all four doors of the car that are going to be used within this application. So for the transport part, as I mentioned, the part is being manufactured in the US. So we have, and then it is being used in Australia. So we have to transport the part from Detroit, where it is being manufactured, to San Diego, essentially the port that we are going to be using to send this part to Australia. Transportation type for this is going to be 32-ton truck. So you can see you have different options to choose from. The distance that we're covering here is 3,750 kilometers. And then we are going to be using a ship to transport this from San Diego to Sydney. And for this, I'm going to be using an ocean freight, which is going to be covering 12,000 kilometers to get this part to Sydney. So that is the transportation that I put in. You can put as many essentially steps that would be required for your own case. For the use case, so essentially, as mentioned, this car is going to be used for 10 years, but let's put that in, and it's going to be used in Australia. So you can see that you have different choices of regions in the world or specific countries. So let's put Australia in. And the mode that we are dealing with is mobile mode, because of course this component, this car door panel, is going to be part of a moving vehicle. So the mobile mode would be appropriate in this case. And so here you can identify the fuel that is going to be used here. So we are essentially dealing with a family car here. So I'm going to put diesel for this case, or gasoline. There it is. So gasoline with a family car. How much is it being used per, how many days it's being used per year is 200 days. And the distance it's covering is 100 kilometers per day. Okay. All right, so that's the use phase. We have put in all the information that we wanted to. This was the user-defined information. So now we can click on summary charts. And as you can see, a summary chart pops up, which with which we would be able to see how different phases of the life of the component is actually impacting the environment in terms of the energy consumption or the energy requirement needed for each phase of life. And also we have the option to have a look at the CO2 footprint as well. So of course we can see that the use case, the use phase of this component is very much dominant as expected. Of course, this is a car going to be burning fuel as we have picked. And so of course, the use phase is significantly more dominant than other phases. But what we wanted to do is to be able to compare our different options in this case. So, of course, one option that we would have in here before bringing in the other materials is, I want to show you, let me reduce this. If you are changing any attributes here live, essentially your chart would change immediately. So for that, for example, if I choose the for recycled content from 50%, I change it to reused parts. You can see that the material phase was essentially eliminated completely because you're not essentially using any energy, or you don't have any CO2 footprints because you're using the a material that has been used before for this part. So that is not being considered for the material phase of this component. But I'm going to bring back to 50%. So I just wanted to mention that when you change things, the chart would change immediately and live. So for that, if you're trying to compare different choices, it might be better to use this compare with option at the top. And essentially, you can create a copy of the current product to change any attribute that you would like, and see how that change essentially compares to the original design choices. In my case, I have a couple of saved files that I'm gonna load in to have a look at how the aluminium and the carbon fiber polymer essentially compare to this steel choice. So I'm gonna bring them in. This is the aluminium one. And let me bring in the composite one as well. There you go. So as you can see, we can immediately see how these three choices compare with each other in terms of both their energy requirements at different stages of their lives, and also, the CO2 footprint. And also, of course, at the bottom, the cumulative effect of these choices is mentioned here as well. So we can see that with if we're choosing aluminium instead of the steel, we would have 34% improvement in terms of the CO2 footprint, and 34% also in energy consumption. And so this can be easily seen how these different options actually compare with each other throughout the life of the components. You also have the chance to click on any of these phases. So as you can see, the use phase is dominant here. If we click on any of the phases, it would directly take us to the help section of Granta Selector, and it provides you with strategies of how to reduce environmental impact, in this case for the use phase. So this is the strategies that can be used for the static mode, but here we are dealing with essentially a moving vehicle. So in a mobile mode in transportation, you can see that, for example, you would like to minimize the mass if you want to minimize the use phase environmental impact. And it shows you, for example, what are the performance indices that you need to keep in mind if you're going to do material selection to find materials that would provide you with light weighting. So that could be helpful in your design as well. Let's go back to there it is. Okay, so that's essentially what I wanted to show you in terms of how the eco audit is used. So let's go back to our slides. And oh, the last thing that I wanted to mention here is that, of course, you do have the option to also create your detailed report as well. And in that detailed report, there is a lot of tabular information about, how much actually is the energy consumption in different phases of the life, how much is exactly the carbon footprint, how they compare with different options. So that could be very helpful for, including in your final report as well. So this is just the results that we just got. Although the composite is providing us with the most amount of light weighting, it is essentially not the best choice when it comes to the environmental impact. Aluminium is, and so that this is something that you could keep in mind when you're designing your vehicle, if you want to consider not only the technical aspect of choosing the right material, but also the environmental or the social aspects as well. Okay, so that is the main two parts of our session today, and now let's say a few words about where you'd be able to get more, essentially get some additional training and support if that is needed going forward. So there are, you might be aware of this, but there are Ansys innovation courses available on Ansys website. These AICs, as we call them, cover a broad range of information, mainly for example, when you're dealing with different software that cover our different physics. It provides you with information about the background of the concepts that you're dealing with when you're simulating, for example, structural or thermal or fluids. So it provides you with more information on that. We also have these AICs for materials. So as you can see, there is a learning track which provides you with information about material performance, elasticity, structure, and processing. So if interested, this could be a very good self-learning resource. It's free. You don't even need to register for it. Just go and have a look. If that would be helpful for you, you can go through the track and find more information about it. When you get these slides, if you click on this link, it would directly take you to this section of the AICs. If you have any questions that you would like to discuss with your peers or academics or Ansys experts, you can use the Ansys forum, which includes different sections. We do have a dedicated section in Ansys forum for materials. And so your the peers and the users of the software are available there, as well as Ansys experts, and you will be able to find a lot of information about how to use the software if you have any issues, for example. And of course, the resource center is also available here within the Ansys website. This would help you if you would like to access, for example, recordings of previous webinars or case studies or white papers. There is a lot of information available in the resource center as well. And finally, Ansys actually runs a series of workshops every year. It's around September, but the actual timing is going to be communicated typically through LinkedIn, and of course, Simcom would be your channel to essentially find this information easier. And this year, we are going to be having a dedicated section on Ansys materials as well. So if you're interested in joining these free workshops, please let Piotr or Basha know, and of course they will be in touch with you as well to invite you for these series of workshops. And I think that's it. That's essentially what I wanted to discuss for today. So at this point, I think we can go through the questions if you have any available in the Q&A session. Yeah, so Piotr.
Okay, Navid, thank you very much for your presentation. So everyone, if you have any questions, please feel free to use chat or to turn off your microphone and maybe ask Navid some questions which you want to find an answer. However, till that, I will ask you, Navid, to maybe show us the live demonstration of using Granta materials database in Workbench, if you can.
Absolutely.
Because
of course.
you mentioned that we can do this during the Q&A session.
Yes.
So let's start with this, and maybe some questions will appear.
Yes, of course. So as I mentioned, let's go to Granta selector first. Let me close this. Go and let's choose one of these materials. For example, if you're dealing with, or if we end up choosing, for example, this polypropylene, if we double click on it and go to the data sheet, as I mentioned, if you right click on this data sheet, you will actually find the export to option, and you can choose to export to any of these commonly used simulation and CAD software. So for example, if you're using Abacus in your design, don't. But yeah, if you're using Abacus, you have the option to export this essentially material data. You have the option to choose temperature dependent and temperature independent type of data. And of course, I would imagine you would like to have temperature dependent. You can export it to a file, and then you can essentially use this file and import it within Abacus directly. So that's one option when you're essentially trying to export this data to other simulation software, which is something that I showed in the slides as well. But you, as I mentioned, because Selector is directly integrated into Workbench, it's quite easy to use it as a material library. So, for example, if you're working within a project in Workbench, you can for example, let's choose static structural. There we go. It is, and so as you can see, within your component systems, you do have the Granta selector option as well. So you can bring it and add it as one of your component systems, and there it is. And of course, you can link it to your model as well, the engineering data, and that is now being used as the source of information for your model. So you can directly launch a Granta selector from Workbench by clicking, double clicking on Granta selector, and it launches Granta selector for you. So let's choose the Metal Plus database. And so let's imagine that you're as part of your design, you want to do material selection, you have done your material selection, you ended up with an aluminium alloy, and you want to use that aluminium alloy within Workbench and to go forward for your static structural simulation. So let's choose one of these aluminium alloys just as a reference material. There it is, 7075 T6. So as you can see, within this data sheet, there is a lot of curve data available, temperature dependent material properties. And so when you right click on this data sheet, as you can see, there is an option added now called export to engineering data within Workbench. So if I click on that, the software asks me if I want temperature dependent or temperature independent. I'm going to choose temperature dependent. And when you click on OK, it tells you that the data has been exported to Workbench engineering data. So you click on OK, go back to Workbench, open up engineering data, and you can see that the aluminium 7075 is now available as one of the materials that you can essentially assign to any of the components that you're dealing with. So within the materials that we have, for aluminium alloy, for example, if I click on isotropic elasticity, you can see that we have the curve for Young's modulus with temperature dependent essentially chart available to us. Similar for the fatigue strength or the essentially the multilinear isotropic hardening, and similar information for temperature-dependent tensile ultimate strength, and so on. So, of course, all of that could be very helpful if you're doing simulation. And it also provides you with a bit more choice because, in sometimes in projects when students are simulating structurally or within fluid simulation, they choose the materials that are available to them. In most cases, for example, for structural simulation, it's going to be structural steel or stainless steel. So this provides you with a lot more option to choose from and have a more accurate simulation as a result of using the right material for the component that you have in mind. So that's how essentially you can use Granta selector material information within Workbench, and of course, this I would imagine the rest of assigning this material to the components that you're dealing with. Does that answer the question, Piotr, you think?
Yeah, I believe yes. It answered the question. I also have one more from my side.
Yeah.
What about introducing user-defined materials? Let's say
Yes.
we have some data from distributor or producer of material, and they vary from the material data properties from Granta, and we want to,
Yeah.
for example, update or introduce this material to the base. Can we do that?
Of course, yes, absolutely. So let's imagine that we're in the same case study that we went through for the car door panel, and we have either a material, as you mentioned, from a supplier, or we have worked on a material in-house and we want to be able to compare the properties of that material to the material information that is available in the software. So for this, you have two different options. If you want to have the more comprehensive option, you can go to Tools, go to Add Records, and you can click on Material Universe, and it provides you essentially with a blank data sheet, and you can fill this in. Let's call it in-house material. You can choose a color for it. I'm going to choose it to be, for example, let's choose aqua. And then, as I mentioned, you have a blank data sheet. So as much information as you have available, you can put it in for price, for mechanical properties. If you have minimum, maximum, whatever information that you have available, you can fill them in. And the essentially software would create for you a data sheet. So let's put, for example, 20 to 100. That's too much. To 50. And click on OK. Well, of course, as much information as you put, you would have a more complete data sheet as well. So if you go to Browse section, there is now a new category called My Records, and that includes the material that you just added. So if you double click on the label, it shows you the data sheet that you created. It just has one attribute because I only filled in one attribute, but it can have as many as you would like. The other option that you're having, if you're only interested in bringing in that material into this chart that you're dealing with. So you can right click on the chart and you can add a record, and then the software would ask you to just essentially populate the material attributes that we are dealing with within this project. So this is a little bit, limited scope. It's easier to, fill this in, and then when you fill this in, the material would be created as a new data sheet, and you can have it on the chart directly as well. So yes, that capability certainly exists, and you can bring in your own material from your research, or if you're, for example, if you're an academic and you're teaching to your students, if you have, I don't know, 5 to 10 materials that you'd be interested in and are not specifically available in the software, you can bring them in by using the add record tool. Yeah.
Okay, thank you very much, Navid. Is there any more questions? Guess not many. So maybe one more from my side.
Yeah.
What about pricing? How often is the price list updated within Granta?
Yes, that's a good question. So the information that is available, let me open up one of the data sheets. So the attributes that are available in these data sheets, they are regularly updated depending on the attributes that we are looking into. The price information, for example, is updated at every release of the software. So essentially, it used to be once a year, it's twice a year now. So that is to have as accurate as possible. It is not, we need to keep in mind that this is not the price information. It's not connected to, for example, a live online source of information that is updated essentially in a live format. So it is more for comparison purposes between different material choices when you're trying to minimize the cost. But if you're going to end up in choosing one of these choices, if you remember, if I go back to the slides and go to the material selection methodology, one part of the methodology is to going through supporting information. So before choosing the final choice, it is always wise to talk with your suppliers. Of course, have a look online in the handbooks to find further information about that, a couple of final choices that you have. Part of this is, of course, having a look at exact price of the material, because most of these or some of these material have very volatile markets, which their price fluctuates a lot. So that is always advised, but within the software, it is updated twice a year, and it can be used for comparison purposes. Other attributes are regularly updated as well. For example, the eco attributes regarding energy consumption and CO2 footprint was just updated essentially, I think, in the last release. That was because, one of the main sources of information that we get our eco properties, which is eco invent, they essentially updated their information on their handbook as well. So we directly updated our information as well. So yes, that's I provided a little bit more information that you asked, but I thought to cover in general how the attributes are updated.
Sure, thank you. It's I guess there is no more questions regarding this. However, if you have any questions after the seminar, feel free to send this via email to me, to Basia, to Navid, and we will try to answer them. And what else? So Navid, thank you very much for your time, for your presentation. I will switch back to Polish just to finish seminar. So thank you very much to be with us today.
Thank you, and thank you everyone else for joining as well. It was a pleasure, and as Piotr mentioned, we are always here. If you have any questions after the session, I'll be more than happy to be in communication with Piotr and Basha to answer them. Yeah, thank you.
Szanowni Państwo, jako że spotkanie już powoli dobiega końca, zakończyła się sesja pytań i odpowiedzi, chciałbym Państwu serdecznie podziękować za Państwa udział w dzisiejszym wydarzeniu. Jakby się pojawiły jakiekolwiek pytania, nie wahajcie się napisać do mnie, do Basi, do Oli. Chętnie na Wasze pytania odpowiemy. Ponadto zachęcamy Was do tego, żeby spróbować przynajmniej skorzystać z tego oprogramowania, jako że obecnie macie je za darmo, natomiast wiele firm poszukuje osób, które potencjalnie będą się u nich zajmować doborem materiałowym, więc to też jest odpowiedni czas, żeby zobaczyć potencjalnie, z jakimi narzędziami gdzieś w przyszłości możecie się spotkać w przemyśle. Jeszcze raz serdecznie dziękuję i na to ostatnie 2 zdania oddaję głos Basi.
Ja również dziękuję Wam wszystkim za udział. Materiały po tym spotkaniu będę przesyłać, myślę, jutro do wszystkich osób, które się zarejestrowały. I oczywiście mają Państwo maila do mnie, więc właśnie, jeżeli pojawią się te pytania, to proponuję skierować właśnie je w odpowiedzi na tego maila z materiałami. To na pewno przekażę je Nawidowi i on odpowie na nie tak szybko, jak będzie mógł. I w takim razie dziękuję jeszcze raz i do usłyszenia, do zobaczenia na następnych spotkaniach.